Hello, welcome to Simplifying Algebraic Expressions. There are a lot of notes on the front end, so please take the opportunity to hit pause and write them all down, and then come back and join us. Equivalent expressions. They're expressions that are the same. Equivalent means equal to. So it's one that is the same as or equal to another one. They may look a little bit different at first, but once you simplify them, you'll be able to find that they are truly the same. So equivalent expressions are those that are the same even though they may appear different, and they'll give you the same value once you simplify. Terms. Terms are numbers or variables separated by a sign or a symbol. This is a term and this is a term. There are two terms in this expression, and then the answer would be a term of its own. But in this expression, the expression is just this part before the equal sign. There are two terms in the expression, three in the whole problem. A variable is just an alphabetic character, A through Z, that represents a number within a problem. We don't know what that number represents. Sometimes it's given to us, sometimes we need to solve for it. But it is an alphabetic character within a problem. Like terms. Like terms are truly just that. They're terms within an expression or an equation that are like each other. They're similar to each other. For the most part, they either have the same variable or they are constants, which we'll see in a minute or two, but they're just constants that also can be combined. Terms are those whose variables are the same. Like terms are those whose variables are the same. 7x and 2x are the same because they both have a single x representing or next to them. 7 and 2 are the coefficients. They're telling me how many of that variable I have. In this case I have 7x's, in this case I have 2x's. Another way that that could be drawn out or written would just be like this. This is also representing 7x's. This is representing 2x's. But rather than writing it out the long way, we shorten it to 7x. Examples that are, or non-examples of like terms are 7x and 7x squared. Again, if you think about that example we just had, 7x's would actually mean this. And 7x squareds means that I have 7x squareds. See if I can get them all on here. So having a list of 7x's and having a list of 7x squareds, they are not the same. These are two different things. They are not the same. A coefficient is very simply just the number in front telling me how many of that item I have. I have 7 x's, so that 7 just tells me how many I have. In this example of a coefficient of 4x, the coefficient is just the 4. It's in front of the x telling me how many how many x's I have in the problem. If we have a number within a problem and the number does not have a variable with it, it's a constant. You learned how to add and subtract constants growing up. Constants can't change. They are that number. If it says plus 2, it's 2. It stands for 2. But in the example of, let's say, 2x, I don't really know what that final number is because I don't know what the x is representing. So a constant is a fixed or defined number in an algebraic expression or an equation. Alright, so let's take some of those vocabulary words and put them into practice. We have an expression here. Notice there's no equal sign, it's just an expression. It has some terms within it. And I want to know a few things. First of all, how many terms? Well, remember the terms were separated by symbols and signs. So here is one term separated by a sign, a minus sign. Here's another term, separation by a minus sign. Here's a term, a plus sign. Here's a term. So I was able to find 4 terms. Those terms that are like terms are 6n, because that's telling me I have 6 n's, 7n, and finally n. Coefficients, now this is the tricky part. The coefficients, remember, are those numbers that are in front of our variables. So this number is in front of our variable, and that number is in front. So 6 and 7 are pretty easy. However, we tend to forget this one. 1 is one of these numbers that we don't always see. He doesn't hang out right up front all the time. But if I can see this letter N, that means there is at least one of them there, so I need to have a 1. The constants, remember, are those that are not affected by the variables. They're always going to remain the same. So I only have one constant in this example, and it's 4. No matter what happens to the other variables in this problem, that 4 is going to stay the same. Alright, you try this one. Hit pause and see if you can figure out these terms, like terms, coefficients, and constants. Hopefully through your work you were able to notice that there were different signs right here separating the terms and that there are 4 terms. Looking through this, I could see my like terms were 9y and 11y, depending on how you look at it. We may look at this as a negative 11y, but I didn't show you that in the last example, so I'm just going to leave it like this for now. However, this also has another set, and we're going to call it 7 and 4. Now notice right now I'm not paying attention to these signs. I could change these, and I'll do that on the next problem. And that would modify my like terms a little bit, but as long as you're recognizing what's happening here. My coefficients are the numbers in front of my variables, so you should have 9 and 11. And my constants are the ones that stay the same, 4 and 7. Now here's what I was talking about. Remember in class how we talk about the fact that we really don't like to subtract. So we want to apply that additive inverse to our problems. So I'm going to do that right up front here. I'm going to change this to add a negative and add a negative. It still doesn't change my terms. I still have 4. My like terms are still the y's. However, now it's a negative 11y and a negative 4 and a 7. This is a little better practice to view them as if you didn't notice that it was a negative 4 the first time, or if you didn't notice it was a negative 11 the first time. My coefficients then are the numbers in front of my variables, which are 9 and negative 11. And my constants finally would be the negative 4 and the 7. Some people look at it this way because they could combine their work from right here. Well, look, from here and here I know I'll have negative 2. Actually, we'll keep the colors the same. I'll have 3 for a constant, and I'll have negative 2 as my coefficients for my variables. Go ahead and hit pause, try this one, come back and we'll see what you got. Alright, terms still 4. The like terms, I'm going to jump in right away and say that my like terms are 3x and negative 3x, because in my brain I already changed that to add a negative. I'm also going to say my like terms are 2 and a negative 10. Again, in my brain I changed the additive inverse here to add a negative. My coefficients are the numbers in front of my variables, which are 3 and negative 3, and my constants are 2 and negative 10. That looks like 70. It should be a negative 10. Let's try again, negative 10. There we go. Alright, so hopefully you did good on those. I have a few more here to practice of combining like terms, but sometimes before we can combine them, we have to simplify them. I'm sorry, in order to combine them, we have to simplify them. So, let's just very simply look at this. We already determined in the last example how many terms are there, what might be common and what might not be. So let's look. I have 1 term and 2 terms. They are like terms because they're both made of y. My coefficient is 4, and my coefficient here, remember, is that 1. I don't always see it, but it's there. This, remember, represents having 4 y's, and this represents 1 y. So if I look at it this way, all it's saying is 4 y's plus 1 y. 4 y's plus 1 y is 5 y's. And I'm done. How about over here? Well, again, the first practice I like to try and use is in my brain or even on paper to switch these to the additive inverse. And then I'm going to take the time to circle my like terms. I see a positive 7x, and I see, after I switch this, a negative 7x, positive 7x, and a negative 7x. Well, a positive 7x and a negative 7x, they total out to be 0, so I'm not even going to write those down. Then I have a negative 2 for a constant plus a 6. Negative 2 plus a 6 gives me a total of 4, so the answer here is 4. I will try this bottom one for you, and then I'll have you hit pause and work out the first two and see what answer you get. Alright, so this is just the leading coefficient of negative 3. I can do additive inverse here if I want to, but it doesn't change anything. I'll do additive inverse here and additive inverse here just so I have a better idea. Then what I'm going to do is I'm going to look and see which one of those are like terms. I see a negative 3d here and a negative d here. Negative 3d's plus a negative d, which is really a 1. So negative 3's and a negative 1, 1, 2, 3, that will give me a total of 4 negatives, and the d comes with them. Now I'm done with the d's. The next thing I want to work on are my constants. I have the constant of a positive 8 and the constant of a negative 2. So positive 8 plus a negative 2. The winner is going to be the positives by 6. So plus 6. My final answer would be negative 4d plus 6. However, what if you decided that you wanted to do the constants first and your answer was a positive 6, and then however you wrote this, whether it was plus a negative 4d or minus 4d, what if your answer was like that? Well, this is where that great commutative property comes in, where it says as long as I'm adding, it doesn't matter the order. This could be 6 plus negative 4d or negative 4d plus 6, and it will give me the same answer because of the commutative property. Alright, so go ahead and hit pause, try these. Alright, here we go. So you notice that your like terms, I did again some additive inverse here, so my like terms were 5n plus negative 3n for a total of 2n. I can't forget about this 6, but the question is, what kind of a 6 is that? Positive 6. So here's my final answer. Again, I could have written 6 plus 2n. That would have been the same thing. But mathematicians usually like to list their variables first if they can. Alright, like terms, I see one here. We're going to additive inverse this guy. So we have a negative 8g here. 2g's plus a negative 8g. The negatives are going to win by 6. And then I have 3 negatives and 11 positives. 3 negatives plus 11 positives equals 8 positives. So if I combine all these together, I have 8 positives here and negative 6g here. And that would be your final answer. I hope you were able to get those. We have a few more to practice. Excuse me. Go ahead and try these really quick. I'm going to just enlarge them. Go ahead and hit pause. Alright, so let's see how you did on these. I'm going to additive inverse each of these just to stay consistent. Again, you don't have to. So now I have 4 negative x's and 10 negative x's. So 4 negative x and 10 negative x, negative 4x plus a negative 10x is a negative 14x. Then I have a negative 1 and a positive 6. Negative 1, positive 6 leaves me with positive 5. And there is my final answer. Alright, and the last one here, I have 8 positive a's, additive inverse, sorry. 6 negative a's, 5 negative a's. 8a plus a negative 6a plus a negative 5a. 8 plus a negative 6 is going to leave me with 2a's plus negative 5a. Positive and negative, negatives are going to win by 3. So that's where we are with that. Then I have 4 positives and 3 positives. 4 positives and 3 positives is 7 positives. And so I write it down, and that's my final answer. Just a few more practice problems for you, but now we're combining some order of operations as well. Don't forget about your order of operations. So as I look through this, we have parentheses, exponents, multiply, divide working from left to right as a group, and adding and subtracting working left to right as a group. So I do see some parentheses here, so let's work out the parentheses. To keep good math practice, I'm going to rewrite my entire problem until I get to this parentheses, 5x's minus an x. So if I have 5 of them and I take away 1 of them, I'm left with 4 of them. So I did my parentheses. Now there are some more parentheses, but all they mean are multiply. So I work left to right, multiplying and dividing. This 5x is going to stay the same. This 4x times 3. Well, if I had the group of 4x and I had that group 3 times, that's going to give me a total of 12 x's. So now I subtract a 12x, and this is the same thing here. I have a group of 4x 7 times, and that'll give me 28 x's. So now I've worked through all my multiplying. My next step would be adding and subtracting, working left to right. However, if I change this into additive inverse, they're all adding. So I can combine whatever I want to combine and work out whatever I need to work out. I'll combine this first just because it happens to be here. I don't see, well, I guess I do see an advantage to adding these because they're all even. So if I had 12 negatives and 28 positives, I'm going to have positives left over, and I'll have 16 of them. Don't forget your x, and then carry down this. Now I have 5 and 16 to make 21x, and that's your final answer. Don't be afraid of the coefficient. That's it. One more. Go ahead and hit pause, see if you can do this yourself, and then come back and we'll see what you get. Alright, so the first thing I'm going to do again is my parentheses, so I'm going to add these together. In good fashion, I will rewrite my whole problem just so I don't get lost on my paper. Two x's plus 6 x's is a total of 8 x's, so I'm going to add up, get 8 x's all together. Now I'm going to rewrite this part of the problem again. Better make that a 15 or I'll get the wrong answer at the end. Multiplying, this is like 1/2. So what is half of 6x? Half of 6 is 3, and so it happens to be negative, but that'll just leave me with a negative 3x. And then these are multiplying as well. Two groups of 8x will leave me with 16x. Alright, so we're getting one step closer. Let's see what we can do here now. Now I have a negative 15x. I can do additive inverse here. Additive inverse, so it's going to lead me to add 3x plus 16x. Since all of these are adding, I can do the commutative property in my head. You can add left to right if you want to, but I see that this 15x is negative, this 16x is positive, and it's a lot easier to combine those because that's going to leave me with 1x for a total of 4x. Now you may have gotten the right answer and done it a different way, and that's totally okay. That's the beauty of the problem, beauty of math. Alright, so that's the last one that I have for you. This was a pretty easy lesson. Hopefully you did okay with it, and I look forward to our next meeting together.